Hey guys, how's everything going? This is JSer who is not good at algorithms. I'm making this video to prepare my future interview. Yeah, let's start. Today it's about 986 interval list intersections. We're given two lists of closed interval. Each list of interval is pairwise disjoint and is sorted order. Okay, like we're getting A, like these are the intervals, and B, like these intervals. We need to return the intersections like this. Well, looks not that difficult. For two, if there's only two intervals, what will happen? Well, we just choose the bigger, if the bigger one, if if there is no intersection, it means one of the right borders is smaller of the left borders, right? Or this right border is smaller than this left border. Other than that, there will be an intersection. And we just choose the bigger left border and the smaller right border. That would be this part, right? Yeah, this is for two intervals. What happens if there are multiple intervals? Well, if there are multiple cases like this, we can first compare the first two, and then because we're getting intersections, the next intersection will only happen on this one, right? Which has the larger right border. It couldn't be on this one because we're sorted, right? The right border must be on the right of this interval. So actually, we could remove it, right? Because this is bigger than it. All the intervals that are happen. Yeah. This is bigger than it. The intervals, if there is, must be only on this one. So we could remove it. So this obviously is a recursion. Not a recursion. We could just do it over and over again, right? Every time we compare the heads of these two lists and get the intersection and remove the smaller one and continue doing a comparison. Cool. So let's start. I'd get intersection and pop and shift the heads smaller. So let's create two pointers. The intersection would only happen if both of them are not empty, right? So it should I smaller than a length and j smaller than b dot length. If one of them is all done, there will be no intersections, and we will create a new array to get the result. Well, what happens now? Of course, we get the heads, right? So a equals ai, that's the b equals a bj. Now we get the intersection. We won't write the logic here. Get intersection AB. We'll create a new function. There are only two cases, which the right border is smaller than this one, or the right border is smaller than this one, right? So if A1 is smaller than B0, or B1 is smaller than A0, then there will be no intersection, right? So for no intersection, what will happen? We return null. For the other case, we just choose the bigger left border and the smaller right border, right? So and for the other case, we return math max A0, B0, and smaller A1, B1. So now we get the intersection. It might be null, it might be a valid. So if there is intersection, we push it into the result, right? And as we said, we will shift to the smaller one. Smaller, shift to the interval with smaller right border. If AI is smaller than or equal to B, if they are the same, it's gonna yeah, if they are the same, it doesn't matter, right? Yeah. If they are the same like this and they are connected to each other, disjoint, they say. Disjoint, yeah. If they joint, oh, if they join, is there a problem, right? Yeah. It's very important that it's disjoint. What happens if it's not disjoint? Well, it actually doesn't matter because this one will not occur, right? This kind of bar. Yeah. Cool. If A is smaller one, we shift A, right? For the other case, we shift B. I made a mistake. We only checked the head, so rather than we shift it, we could move it further, right? We should move I plus 1. If B is smaller, J plus 1. And finally, we return the result. Uh-oh. We're not getting the right answer. What happens? We're getting the intersection. We push the intersection and remove the smaller one. Aha. I know what happened. Cool. We're accepted. Actually, I think we could write it another way. We stop using this one. We will use shift or B shift. So we only get the head, right? So it's like this. So A dot length, we get at 0, and B dot length, 0. I think this should also work. Let's try. Yeah, still working. Cool. We accept it, and let's analyze the time and space complexity. For the time, all the intervals are traversed only for once, so if suppose there's m and n intervals, not actually every time we at least remove one intervals, right? So it's linear time. Space, we don't use any extra space. The result, because it's result, it should not be counted as extra space, so it's constant. Cool, that's all for this one. Hope it helps. See you next time. Bye-bye.